Alright, problem number 4. Aaron, Brendan, and Calvin are the winners of a contest for a pile of candy, which they are to divide in a ratio of 3 to 2 to 1, respectively. Okay, so that means that if Calvin gets 1, then Brendan gets twice as many, which would be 2, and Aaron would get 3. Okay. Due to some confusion, though, they come at different times to claim their prize, and each assumes that he is the first to arrive. If each takes what he believes to be his correct share of the candy, what is the fraction of the candy that will go unclaimed? Alright, well, let's first of all try to figure out what share they think they are entitled to. Okay? So if if Calvin, let's just draw a block. So this is a block to represent the amount of candy that Calvin would get. Okay, and if Calvin gets 1 block, then Brendan gets 2. Okay, he gets twice as much as Calvin, and then Aaron would get 3. Okay, 1, 2, 3. Okay. So essentially, okay, so this is Aaron, okay, and this represents Brendan, okay, and this is Calvin, and so of the total amount of candy, Aaron, if he comes and he's by himself, and he thinks he's the first person, he's going to take half of the candy, right? 3 out of 6, okay? And Brendan is going to take 2 of 6, which is a third, so he thinks he's entitled to a third of the candy, and Calvin will get a 6th, okay? Does that make sense? So those are the fractions that they think they're entitled to based on the ratio that they're supposed to divide the candy into. Okay, so let's take a look at what would happen with Aaron and Brendan and Calvin. Let's make a little table. So here we have Aaron, Brendan, and Calvin. And so let's figure out how much they take and also how much they leave, because how much they leave behind is going to be what the next person sees when they come to take their candy. Okay, so let's say, for example, that Aaron comes first, and he takes half of the candy, and he leaves half of the candy. All right. Let's say that Brendan comes next, and he sees half sitting there, and he takes 1/3 of 1/2. Okay, so we can figure that out by 1/3 times 1/2. Okay, and he's going to leave 2/3 of 1/2, right? And so let's say Calvin comes last, and he's going to take 1/6 of, actually I could write this out, or simplify this. This would actually just be 1/3. Okay. So he's going to take 1/6 of what Brendan left, such as 1/3 of the candy. Okay. And the amount that he's going to leave is 5/6. Oops, 5/6 of 1/3, the amount left, which is going to give us 5/18. Okay, so if Aaron, Brendan, and Calvin come in this order, they're 5/18 of the candy is going to be left. Okay, so the question is, does it matter what order they come in? Because essentially the amount of candy that's left is going to be 1/2 times 2/3 times 5/6, right? Because if Calvin comes first, he's going to take 1/6 of the candy and leave 5/6. and then Brendan will take a third of what's left and leave 2/3, and then Aaron will take half and leave half. Okay, so since multiplication is commutative, no matter what order they come in, um, the amount that's going to be left is just going to be 5/18. Okay. Now, it will make a difference as far as how much candy they get. So, like if Calvin comes first, and let's say there are 18 pieces of candy, he's just going to take one of them, right? He's just going to take a sixth of the 18, right? No, wait a minute. So, if Calvin comes first, I should say. All right, so he's going to take, yeah, so if Calvin comes first, he's going to take a sixth of the 18, and he's going to get 3 pieces of candy, right? Sorry. And but if he comes last, he's going to take 1/6 of what's left, which is just going to be an 18th. Okay, so he's only going to get one piece of candy if he comes last. So the amount that the kids get individually will vary depending on what order they come in, but the amount that's left will be the same because multiplication is commutative, so it doesn't really matter who came first. What's left will be 5/18 of the candy. All right, so there you go.